Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Question 7 states that example 1 discusses the concepts that are relevant to this problem. So if you're looking at textbook, example 1 is just noting based on an observed dose or observed energy, the change in temperature that can be observed. So I recommend looking at that question before going through this problem. So assuming that you did, this question also states that a person undergoing radiation treatment for a cancerous growth receives an absorbed dose of 2.1 gray. All the radiation is absorbed by the growth. If the growth has the specific heat capacity of 4,200 joules per kilogram per degree Celsius, determine the rise in temperature. So we're assuming it's the same as water. So provided to us in the book, we do know the relationship between specific heat, temperature, and energy, and mass, of course, where we simply have it to be the mass times specific heat multiplied by the change in temperature. So based on what we are given, we can rearrange this to solve for this change in temperature. So if we're, again, solving for delta T for this problem, we can rearrange this equation to be energy per mass. I kind of spilled the beans there. All over, oh no, sorry, not true. Over specific heat. But we note that this energy per mass, Q over M, is simply just the dose over specific heat. Our dose is given. We'll see if we need to convert any units. So we have 2.1 gray. Remember, gray being joules per kilogram over 4,200 joules per kilogram per degree Celsius. And just looking at your units, joules per kilogram is simply just gray. That cancels out with gray. Our units on our denominator are 1 over degree Celsius, so that we would have our term being in Celsius. And simply doing this division, we find that the change in temperature, very small, to two significant figures is 5.0 times 10 to the negative 4 degrees Celsius. So there you go.